Hi, welcome or welcome back to Physionic. In today's detailed study analysis, we're going to be looking at a study that looks at three different groups of individuals: people who are normal weight, overweight, but otherwise healthy, as in their blood markers don't show any sort of dysregulation like high blood sugar, triglycerides, things of that nature. And the third group is overweight individuals with diabetes, type 2 diabetes. But before we get into that, which looks at insulin sensitivity, I'd also like to let you know that if you're interested in more content like this, I'm going to be, or at the time of this recording, it will already have been released, a meta-analysis. So looking at a particular study that groups over 100 different studies looking at the effects that polyunsaturated fats, monounsaturated fats, saturated fats, and carbohydrates have on insulin sensitivity and insulin levels and blood sugar levels. So this analysis looks at 100 studies to compile the overall evidence for or against particular diets incorporating those four components. And it also stratifies based off of age, sex, and a series of other marking factors that might be of interest to you. Well, if you're interested in accessing that, then join my Physionic Insiders group community, which I will have a label or some sort of ticker that'll pop up in case you're interested in joining that. I'll remind you at the end of this episode as well if you don't want to leave, which I certainly don't blame you. Okay, if you're not familiar with who I am, my name is Nicholas Verhoeven. I'm a PhD candidate in molecular medicine, and I love reading research. I've been reading research for many years now, and this is what I do. This is what the channel is largely about. So today, as I mentioned, we're going to be looking at I guess I'll go ahead and start it, a paper that aims to answer this question. So how do a heavy polyunsaturated fat diet and a heavy saturated fat diet fare in measures of insulin sensitivity? Now, there's going to be something really interesting that I will leave for the very end of this video, but I'm going to prime you now that you should really pay attention. That's what I'm going to say. Really pay attention to some of the things that I'm going to be pointing out, because the conclusion is going to be unique. We'll put it that way. All right, so the topics that we're going to be covering is actually not only insulin sensitivity, but also fat distribution. So they looked at changes in fat distribution on either diet. And the information comes from this particular study, which is in this is always difficult for me to say the journal name, Diabetologia, which is a really reputable journal, and I've covered several studies from this journal. But ultimately, this is the study we're going to look over, and it'll be linked for you in case you want to check it out in more detail than even what I'm covering here. All right, so this is the basic design of how they went about this study. They had 17 participants, men and women, that were roughly 50 to 55 years of age. Maybe one was maybe 56 years of age for the three groups. Three groups were normal weight individuals, overweight but otherwise healthy individuals, and overweight and diabetic, type 2 diabetic individuals. And they put them into two different diet groups. So this is a within subjects design, meaning that all these individuals are going to be on the saturated fat diet for 5 weeks, and then they will be switched over to, all of them will then be switched over to the unsaturated fat diet, which they've got labeled as the unsaturated or the polyunsaturated fat diet. So the researchers take measurements for insulin sensitivity, for example, or the other measure of fat distribution at baseline, so before they're on the saturated fat diet or the unsaturated fat diet. Then 5 weeks later, they take another measurement for, let's say, the saturated fat diet at the end of those 5 weeks to see if there was a change against baseline. And then the unsaturated fat diet, they do another measure at the end of that. And this is the basic study design. Now I'm going to give you some more details on the actual nutrition makeup of these diets. Okay, so here, again, as always, this, if you've been following Physionic for a while, I'm always going to say this. This is a bunch of numbers. It's actually really simple to read through. You've got your energy intake here, which is your caloric intake. Here they've got it measured as megajoules. So megajoules are, I believe, 1,000 kilojoules, and you've got 4.18 kilojoules per calorie. Do you need to know that really? No. Just know that this is what you would normally see as a calorie consumption. And we see that 10.4, 10.6, and 8.9. And we look for the significance. If the significant values less than 0.05 is what these researchers set it as, then that means there's a significant difference between these. But here we see that 0.07, so it's not technically significant. I'm gonna pause here for a pregnant pause to add emphasis here. It is technically not statistically significant. Okay, let's move on. So carbohydrates was not significant. Fat intake was significant, as in probably between this one, the saturated fat diet, and the polyunsaturated fat diet. You can see that the total fat levels were lower in the polyunsaturated fat diet. So saturated fat, polyunsaturated fat in the baseline diet. So this is before they were put on each diet. So this is what they came in with. Then the protein levels were non-significantly different. Again, you see that 93 is obviously lower than 104, but these values beside it show the range. So there isn't enough certainty, statistically speaking, to say that there's an actual difference between those two. So statistically, there's no difference. Saturated fat content, they were consuming about 36 grams on average with the baseline diet, and then they were consuming 58 grams, so a decent increase in the saturated fat diet, which is obviously why it's called the saturated fat diet. And then they lowered it for the polyunsaturated fat diet. And then we've got monounsaturated fats and polyunsaturated fats. Here again, the saturated fat diet had reductions in polyunsaturated fats. They maintained roughly their monounsaturated fats, but there was a significant increase in polyunsaturated fats with the polyunsaturated fat diet. Hence the name, the polyunsaturated fat diet. Now, trans fats were, again, not technically significantly different between the two. However, it does seem like it's at least trending towards being a little bit higher for the saturated fat diet. Now, something that I noticed, which I put in my notes, which I'll quick scroll down here real quick, that there are several inconsistencies, which I'll just point out one of them here, and then we'll return to it. The inconsistency here is that if you add up the fats, they don't add up to the total fats, which is peculiar. I don't know how the reviewers missed that. Maybe they did some sort of mathematical error, or I don't know what's going on there. But there's an inconsistency. If you add up all these fats, including trans fats, then you don't get to the total fat level that they ended up consuming. Odd. Now, looking at the ratios of omegas, so you've got omega-6s and omega-3s. There was no statistically significant difference between those. Fiber, again, no statistical difference between those. So we're going to return to this. I'm just going to let you know now. But for the time being, if you're thinking, there may be some problems here, or you feel like there's some notable issues or inconsistencies that you might find, please post them in the comments, because you may be right. I'll just leave it there. All right, so let's look at the actual data. So looking at the body weight. So remember, this is measures that were done at the end of the 5 weeks. So at the end of the 5 weeks on the polyunsaturated fat diet, and then at the end of the 5 weeks with the saturated fat diet. And statistically speaking, there were no differences in their body weight. Same with their BMI. There was a slight increase. There was an increase in total cholesterol with the saturated fat diet. And there was also an increase with LDL particle cholesterol, so that low density lipoprotein part of the cholesterol. Now, the main measure that we're interested in here is insulin levels and insulin sensitivities more specifically. And insulin sensitivity was dampened or reduced in the saturated fat diet. So here we get an answer to one of the major questions that we were interested in. But as I said, we'll be returning to this. And then none of the other measures were different. Triglycerides, non-esterified fatty acids, so the fatty acid levels, glycerol, all those were the same or statistically the same between these conditions. Now, moving on, however, we can look at the fat distribution. So subcutaneous fat is the fat that's, found under your skin. It's, what hides your six-pack and things like that. So it's the fat that's found under your skin. The visceral fat is the fat that's found around your organs, is typically considered to be more detrimental to your health than subcutaneous fat or increased subcutaneous fat. So trying to lower your visceral fat is typically best, although generally losing body fat is normally considered a positive. Now, here's the grouping of all the subjects, so all the participants of the study, and then they've got it broken up by the type 2 diabetics, the obese individuals, and then the normal weight or non-obese individuals. And this is the fatness level in the subcutaneous fat region, specifically measuring subcutaneous fat with the saturated fat group and here with the polyunsaturated fat group. And we're looking at the comparisons between those two. And what we find is that with all subjects taken into consideration, there's a drop in subcutaneous fat, specifically when the individuals were consuming the polyunsaturated fat diet. The same was also true for then we stratify it. So all the subjects is obviously encompassing all three of these. So if we get more granular and we just look at the obese individuals, we see that there was this effect that happened here for all subjects was especially true for the obese individuals and for the non-obese or normal weight individuals. However, we did not see that for the type 2 diabetic individuals. So that means that if all the subjects were type 2 diabetic individuals, this would not be statistically significantly different. But because these two groups exist, they are driving the overall effect down, as in they're increasing the effect. Another way of saying that is they're decreasing body fat as measured by subcutaneous fat. Because these two are significant, it overshadows the type 2 diabetics not having a change. Hopefully that's clear. Now, shifting our focus to visceral fat is literally the exact opposite. So it just gets flipped on its head. There's no difference when we're looking at with all the subjects, but when we actually stratify based off of, type 2 diabetic, obese, and non-obese, suddenly we see that the two previously that showed decreases in fat mass in subcutaneous fat suddenly don't see a change when looking at visceral fat. However, the diabetic individuals experience a significant decrease in their visceral fat. So this is pretty interesting just because here it shows that people without type 2 diabetes tend to lose more. Well, one, it tells you that the polyunsaturated fat diet led to fat loss. And secondly, it tells us, or compared to saturated fat, and the second thing that it tells us is that the polyunsaturated fat diet leads to specific fat loss that is under the skin, that is more superficial, and in the type 2 diabetics, the polyunsaturated fat leads to reductions in visceral fat. So this is kind of unique, kind of interesting. Okay, but that said, what conclusions can we make from this? Well, there you have it. Those are the conclusions that we can actually make from this. So no accurate conclusions can be made based off of the available data. So why did I say that? I've been keeping things pretty shrouded, pretty veiled up to this point because I wanted to see if you've commented up to this point, or if you've just been thinking about it, what could be some of the inconsistencies with this study, which I was frankly pretty blown away that this study was published in such a reputable journal when there were multiple areas that were problematic. But I digress. Maybe I'm missing certain things, but I'll point out one thing with basically each slide. So the first thing that's inconsistent or that's a poor way of going about the study is that typically if you're doing, excuse me, if you're doing a within subjects design, what you typically want to do is have a washout period between these two diets, because it's unfair to make comparisons when you have a baseline measure. And let's say they did the unsaturated fat diet first. Let's say they saw significant improvements in their health and whatnot with the unsaturated fat diet. Maybe they lost weight, whatever. Then what you need to allow is for the body in general to go back to baseline. You can't go from an unsaturated fat diet and then jump straight into a saturated fat diet, because the delta or the amount of change that occurs will be more significant as a result. You have to allow the body to go back up to its baseline. Let's just in a hypothetical situation, say that the unsaturated fat diet has remarkable benefits, health benefits. Well, if you go straight from there back to the saturated fat diet, then you're going to go from remarkable benefits to sudden, really bad health effects. So you're getting a double whammy of the great benefits of the unsaturated fat and the negative effects of saturated fat, which you might think that's fine, but in reality, that's an unfair comparison, because the unsaturated fat is being compared against baseline, and then the saturated fat is being compared technically against the unsaturated fat diet. It's not being compared in the similar realm against baseline. So you have to allow the body generally to then increase or go back up or change back to the baseline levels by allowing them to go back to their normal nutrition. So that's one critique. And typically you want this to be many weeks, maybe even months, before they come back in and then do the unsaturated fat diet. Now, one thing I did like is that these individuals continuously checked in with a dietitian, so that they tried to make sure that everybody stuck to the nutrition plan that was provided for them. Okay, so that's one critique. Is it an end-all be-all critique? Is it a problem completely? No, but I think it's something that at least I would prefer. And as far as I can tell, they didn't do that. Another problem here is, I told you about the inconsistency between the fat addition up to the total fat. It doesn't add up, so that doesn't make much sense. I don't know what's going on there, but maybe that's just some oversight. Another thing here is the energy intake. So I gave the pregnant pause when looking at the energy intake, because sure, if you're looking at the baseline versus the saturated fat, there's definitely no difference in the energy intake for those. However, with the polyunsaturated fat, with a p-value that low, even though it's technically not below 0.05 and therefore it doesn't meet the criteria, it's inaccurate. I think it's just wildly inaccurate, actually, to look at a number like that and a p-value that's so close to being statistically significant, especially with so few participants, and then for you to then go, oh, well, there's no difference. No, there's probably a difference. And over 5 weeks, there's probably a difference that's occurring that is potentially not happening because of the polyunsaturated fat diet, but because of the weight loss that's occurring. Now, granted, they mentioned that they wanted everyone to maintain their weight. So the idea was for the study to be designed so that everybody maintained their weight, so that just the changes in those macronutrients, just those changes in the saturated fat diet or the polyunsaturated fat diet would be leading these or causing these effects. But based on this, I would not feel comfortable saying that, oh, yes, it's because of the polyunsaturated fat diet that we see this maintenance or this improvement in insulin sensitivity or these changes in body fat distribution, because we simply can't say that, because I think there is a statistical difference or an overall real world difference in their food consumption. So that's another thing. Another thing, of course, is the trans fats. I don't think it's as big of a factor, but it technically is getting very close to statistical significance. So here, the saturated fat diet had higher trans fats. So how do you know that it isn't the trans fats that are causing some of these negative effects and not the saturated fat diet? And keep in mind, I mean, I have so much content at this point implicating saturated fats to have all these negative effects when it comes to insulin sensitivity. But here, I mean, to be fair, we just can't jump to those conclusions because of all these inconsistencies. Now, here I mentioned, let me go back one real quick. Remember, I'm really harping on this idea of reduced energy consumption. And then, sure, somebody could then come back and say, well, yeah, but their weights weren't any different. See, that's the tricky thing. See, the weights weren't any different at the end of their respective diet period. So the saturated fat on the saturated fat diet or the polyunsaturated fat diet. But in reality, what they should have shown is the actual overall change from baseline. So from baseline to the end of each diet, saturated fat and polyunsaturated fat. Because here it's possible, I'm just throwing something out there, I'm not saying this is the case, but it's possible the polyunsaturated fat diet group started out at 85 kilograms and then they lost weight to 80.8 kilograms, and they're just showing, oh, there's no difference in the end weight. But really what I'm more interested in is the difference. Was there a change? Because if there was a change, that would mean that this is a huge driver, that we're seeing the polyunsaturated fat diet have a negative calorie balance. So they're consuming fewer calories. So, and this could be the reason why we see this this higher insulin sensitivity with the polyunsaturated fat diet, and why you might see reduced, let's say in this situation, reduced cholesterol compared to the saturated fat diet. This is just too many inconsistencies here for us to then say, oh yeah, the polyunsaturated fat diet has a positive effect on insulin sensitivity. Now, if you want to go as far as to say is the polyunsaturated fat diet forces people to consume less food, and therefore the combination of less food plus a polyunsaturated fat diet leads to improvements or overall maintenance of insulin sensitivity, that's a fair argument. But again, we're still talking about too many inconsistencies with like the trans fats and things like that. You're introducing more and more variables as we're going along that are changing. So now we can't point to one variable and say, oh, this is the reason. It's because of the unsaturated fats that we see this change in insulin sensitivity or the body fat distribution. But because we see unsaturated fats change, we see trans fats change, and we see food consumption change, that's three variables just off the top, not to mention the study design, which I didn't particularly like, that would lead to all kinds of different interpretations. So my conclusion is that the data is insufficient, or it's just not designed well enough to warrant a strong conclusion any one way or another. So this is I would say a faulty study that if anybody were to base their nutrition recommendations or any sort of recommendations on saying that saturated fats are a poor diet if you want to preserve insulin sensitivity, or that polyunsaturated fat diet is a good diet to preserve insulin sensitivity, you would be demonizing saturated fats unfairly. That's what I would say. But, again, keep in mind, I've got plenty of other content that shows that saturated fat typically, so far, up to this point, up to the point of this recording, does not seem to be beneficial for insulin sensitivity. So that whole last 10 minutes was me just sort of ranting about the different problems of this study. But if you want to hear more on this kind of stuff, especially as I mentioned, the meta-analysis of over 100 studies instead of just one study, my analysis of that, then hop on over to the Physionic Insiders if you want to hear me rant more or just want to see more of these types of analyses. Then hop on over to the Physionic Insiders, which I'll have linked for you, and it's exclusive content. So all the content in the Insiders program is just for those individuals, that community. And I'm hoping to have a lot more of this kind of discourse back and forth, because there is a text system within that program so that people can reach out to me and we can actually have dialogue back and forth, kind of analyzing and thinking about some of this stuff, and maybe pointing out things that I miss. So if you're interested in that, then and you want to support my work as well, then this is the greatest opportunity to do that. And with that, if I will leave you, and hopefully you learned something, and I'll catch you in the next one.